So I've just been reading John chapter 2, which is the story. Well, it's the first half of it is the story of Jesus turning water into wine. Now, what's curious about this is that it's only in this. It's the only one of the Gospels. Matthew, Mark, Luke, John are the 4 Gospels. John is the only one which talks about this miracle. And so if all 4 of them talked of the miracle, it might have a tiny shred of credibility. But with one of them, a single person, not as likely. Like the story of Jesus healing the man with palsy, that's mentioned in 2 or 3 of the Gospels or something, that gives a tiny little bit of credibility, but I still think it's bullshit once you read it. So water and the wine, it's essentially, I'm reading, my reference text is the King James Bible. So, and the only reason, I know it's outdated, the reason I like the King James Bible is that it's written not in Old English, which I just find a bit more entertaining. That's it. That's the only reason. But, so, on the 3rd day there was a marriage in Cana of Galilee, and they have no more wine, blah, 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 fill 6 water pots, the whole shebang. Now, essentially, what I wanted to say is, if you're gonna turn water into wine, that is gonna have to be a change from a simple dihydrogen oxide, well, dihydrogen monoxide, so H2O, or HOH as chemists prefer to think of it. You can changing that into a very complex mixture of ethanol and glucose and various other things. So essentially, you're going to have a super complex chemical reaction, which is if you added something else to it, but there's no mention of adding anything else to the water. It just says happen. So if you eliminate chemical reaction, you're left with the nuclear reaction essentially. So the volume would be lessened, because you're using a whole ton of protons. Actually, all of the volume be actually, ignore that. That might be wrong. But nuclear reaction, you're changing. Let's just take a few molecules. You got the 6 atom. Sorry. You got a hydrogen atom. You got the protons, the neutrons, and the hydrogen atom. Then you got the protons in a hydrogen atom, which is essentially a proton, because you got the electrons spinning around the outside, and we can just ignore electrons since it's a nuclear reaction. So you got 8 protons in an oxygen atom, and then you got 2 on the side. So you got 10 protons all up in one molecule, and then you would have 6 neutrons, because there's no neutrons in the hydrogen, and there'd be 8, actually 8 neutrons. Sorry, I'm a bit tired. So you got to have a really complex nuclear reaction, because you're not just making a single element from another one, from like uranium decay all the way down to thallium and lead and that sort of stuff, and that's not what you're having here. This is a really complex nuclear reaction where you're having the protons swap around and the all that sort of stuff. So if you understand if you have a senior high school level of understanding of nuclear chemistry and nuclear physics, which is not a very high amount, but enough to assess this problem, you'll understand where I'm going. So you're just basically switching protons around to create new elements. So instead of having hydrogen and oxygen, you're having carbon, hydrogen, oxygen, nitrogen, maybe a little bit of sulfur, stuff like that. Essentially, but the main one that you've got to create is carbon. And frankly, 2,000 years ago, or around about 2,000 years ago, no nuclear reactors, anything like that. With a nuclear reaction, it's bogus. So yeah, but if it would have had to happen, that's what I understand it to have gone through a nuclear reaction. So 1 and 1, busted.